Limits.
Math guy the... Wait.
Math guy, the math guy.
Math rules.
Limits. The value that a function or sequence approaches as it goes along the graph. But the important thing to note here is that it never actually reaches that value. Take my two fingers here. Let's say I half the distance between them. Let's say I halve it again. And again. And again. They're gonna get really close. Infinitely close.
Wow.
And that's what limits are. They'll never touch.
Math guy,
Yeah.
why exactly are you ripping off Bill Nye?
Well, if I wasn't, you wouldn't exist.
Touche.
So here's a limit. Looks complicated, right?
If you say so.
This right here means the limit as x goes to a number on the function is this value. Now on the graph, we can see just that. The graph as x goes to the number is that value. Pretty easy, right? You don't gotta go to math college to get limits. It's easy. Now there's another property about limits you have to understand. You see, both parts of the graph have to be going to the same place, like my fingers. So if the limit goes like this, or this, or this, it doesn't exist. It has to go to the same place. Take this piecewise graph, for example. On the left half, it's going towards another value, but on the right half, it's going to a different one. The limit doesn't exist. Doesn't exist. Doesn't exist. Doesn't exist. Now how exactly do you solve limits anyways? We're in math, right? You gotta solve stuff. For most limits, all you have to do is plug in the value that it's approaching. Just like you would any other equation. However, you can't plug into just any other function. Take this one for example. If you were to plug in a 0, then the 0 would be on the bottom. And you'd be dividing by 0. Trust me. Do not. For these such functions, you'll have to do things like factor both sides, and maybe you'll be able to cross something out. But always make sure to include that x or whatever variable can't equal that function. Because it can. There's just going to be a hole in the graph. Other limits that you might do include something called a conjugate. It's where a square root is adding or subtracting to another square root. And that's on top of 2 more square roots. How do you think you're going to do that? It's easy. All you have to do is multiply the function by the conjugate of the bottom. Meaning, it's the same, you just change the addition or subtraction to the other one. And then it all cancels out and you can factor it pretty simply.
Did you know that?
There are also limits called infinite limits, where both parts of the graph go up to infinity. Either positive or negative. But keep in mind, positive infinity is not the same thing as negative infinity. So if one goes one way and the other goes the other, they won't exist. Imagine going to infinity. Like being infinitely close. It just gets me all... Yeah!
Now you know.
It's easy. Child slaves, tell me more about limits.
Here's what you do at home. Get out a math workbook and work on some problems about limits.
Well, what exactly can limits be used for? One thing is a continuity test. This test takes 3 steps, and it tests whether a graph is continuous in a certain place or not. The first step is to make sure the graph exists at that place at all. I mean, yeah. The second step is to make sure the limit exists at that point. So basically, the graph heads to that spot. Now the third step is also very, very important. It's to make sure both the numbers in step 1 and step 2 are the same one. Take this graph for instance. You see, in step 1, the graph definitely exists at this point up here. And in step 2, the limit definitely exists right there. But we both know that this graph is not continuous. So that's why we have step 3. In order to prove dirty, rotten, traitorous liars like this one, worthless piece of, there we go. Worthless, discontinuous graph. And that's how you do a continuity test with limits.
You're gonna rap about limits, and I'll take only 30 minutes. Just have a rest and sit up straight and listen to my flow about kanji. Garbage.
So that concludes our presentation on limits. Well, there's much more stuff you can do with it later on, but for now, we'll just stick with the basics. Just make sure you remember them though, because they can always come back to... Oh my god. Functionia integralis! I'm not gonna make it!